QST bar সবাই জেনে তাই জেনে সহযোগী নিবেদন ডাফ এন্ড ডাটের গ্রামার কোশ্চেন ফর এ পারফেক্ট কাপ অফ টি শালিমার শেফ গুঁড়ো মশলা জীবনের আসল স্বাদ
আপনাদের সঙ্গে আমি কুসুমিতা লকডাউনে ক্লাসরুম আমাদের এই বিশেষ অনুষ্ঠান প্রত্যেকেই যেমনটা জানেন যে উইকেন্ডে আমাদের আইসিএসসি এবং আইএসসি ক্লাস হয় আজ শনিবার আজকে আইএসসি ক্লাস এবং আজকে আইএসসি আমাদের আলোচনার বিষয় অঙ্ক ম্যাথমেটিক্স ইজ our today's subject and today's topic is matrices and we'll discuss on it in Council for the Indian School Certificate Examination selected teacher Mr. Sanjay Datta is our today's guest. Sir, welcome to our program. First of all, I'd like to ask you that during this lockdown period, the students are getting bored staying at home. But this time is very important to prepare themselves whenever they are staying at home. So, what are the processes and how should they prepare themselves?
When students of class 12, they should first revise the topics that they have learned in class 11, formulas of trigonometry, basic differentiation, whatever they have learned, they should revise those topics, and then from class 12 part, they can begin with relation functions, because functions they have done in class 11, and then they can proceed to differentiation, algebra, these parts. For students of class 11, I would suggest there are chapters like APGP, trigonometry, linear inequalities, which they have done in class 10. They should start with those topics to revise at home and use this lockdown period for the benefit and so they can prepare themselves for the upcoming examinations.
Sir, today our topic is matrices. So yes. What is the definition of matrix and what are the types and the variations?
Yes, ma'am. First, to define a matrix, I would take help of something that all of you are very much familiar with. First, let us observe a school timetable. Now, all of us are familiar with the concept of the school timetable. Slide, please. Now, if you look on the screen, the school timetable that you can see, it is a rectangular arrangement. The horizontal lines called rows and vertical lines called columns. On the left side, you get to see the days of the week. It's Monday, Tuesday, Wednesday, Thursday, and Friday. And at the top, you get to see the periods written in a horizontal line. Now, if you note that the intersection of the first row, that is the row line related to Monday, and the first column, that's the intersection of the first period, that gives us the subject that is taught on Monday in the first period. Now, the horizontal line represents all the subjects that are taught on a particular day, and the vertical lines represents all the subjects that are taught in the first period. Now, if we refer, say, the second column that is marked by 2 and we choose Wednesday, the intersection of the row corresponding to Wednesday and the column corresponding to 2 will give us a subject that is taught on second period on Wednesday. Now, using this concept of a rectangular arrangement, let us define what is a matrix. Next slide, please. Now, see what is the definition of a matrix? A matrix is a rectangular arrangement or array of numbers, symbols, expressions arranged in rows and columns. Now, 3 words, it's an array of numbers, symbols, and expressions. Let's see an example. Capital A is a matrix whose elements are 1, 2, 3, 4, 5, and 6. Now, clearly, these are numbers. This is a matrix whose elements are all numbers. The first horizontal line represents the first row. The second horizontal line represents the second row. The first vertical column represents the first column. The second vertical column represents the second column. And the third vertical column represents the third column over here. So, there are 2 rows and 3 columns. Now, it is very important that when we write a matrix is named using capital letters and we use either the first bracket, like over here I'm writing 1, 2, 3, 4, or the third bracket, like 1, 2, 3, 4, to denote a matrix. It is a very common error we see that students during the examination use this symbol. Now this symbol is incorrect. This is the symbol for a determinant. Be very careful when you are defining a matrix, then you should use the correct symbol, either this or this. The elements of a matrix are always written using small letters, and the matrix itself is named using a capital letter. Now let us see a few more examples. B is another matrix where the elements are X, Y, Z and W. Now these are all symbols. C is another matrix whose elements are, first element is X plus Y, second element is X minus Y, third X square plus Y square, and fourth X square minus Y square. Now these are all mathematical expressions. So the first matrix is using numbers, the second matrix elements are all symbols, the third matrix the elements are all mathematical expressions. So all this rectangular arrangement form a matrix. Now the concept of matrix is clear. Let us define what is order of a matrix. Slide please. First, this last slide again. Now order of a matrix. The order of a matrix is that if a matrix A consists of m rows and n columns, then the order of a matrix is m by n. Although we pronounce it as m by n, but when we write m cross n. So if we look at the first matrix, there are 2 rows and 3 columns. So order is 2 by 3. The second case, there are 2 rows and 2 columns, so order is 2 by 2. And the third matrix, there are 2 rows and 2 columns, so order is 2 by 2. So order of a matrix means first the number of rows followed by the number of columns. So first comes the number of row, then comes the number of column. Now based on this concept of order, let us define what is a comparable matrix. Next slide please. Now comparable matrix is that if A is a matrix whose elements are 1, 2, 3 and 4, and B is a matrix whose elements are X, Y, Z and W, the two matrices having the same order are called comparable matrices. So order of A is 2 by 2, order of B is also 2 by 2, so A and B are comparable matrices. Now we define what is equal matrix. Very important. Two matrices are said to be equal if and only if they are of the same order and their corresponding elements are equal. So let us define one more matrix C whose elements are 1, 2, 3 and 4. Now clearly in matrix A and matrix C we see they are of the same order. So first condition that they must be of the same order is satisfied. The second case is that all the elements 1, 1, 2 with 2, 3 with 3, 4 with 4, all the elements are equal. So A and B are equal matrices. Equality of matrix is a very important concept and we'll use it later today while solving a lot of questions. Let us now go to types of matrices. Now, types of matrices are defined using the number of rows and number of columns present in a matrix. So, let us see the first type, that is a rectangular matrix. Now, what is a rectangular matrix? A matrix which consists of m rows and n columns, where m is not equal to n is called a rectangular matrix. So, if A is a matrix, elements are 10, 11, 12, 13, 14, 15. Now clearly there are 2 rows and 3 columns. So order is 2 by 3. Because the number of rows is not equal to number of column, it's a rectangular matrix. Also, we see that the shape of such a matrix is rectangular, and hence comes the name. Now we define a row matrix. A matrix consisting of only one row of elements, say 1, 2, 3, is called a row matrix. So there is only one row and there are 3 columns. So if there is only one row and 3 columns, then such a matrix is called a row matrix. The order of such a matrix is 1 by 3. Now we define a column matrix. As the name suggests, a column matrix is a matrix which consists of only one column. So suppose C is a matrix. The elements are X, Y, Z. There are 3 rows, R1, R2, R3 and 1 column. So order is 3 by 1. Next type is a null matrix. Null matrix is very important because null matrix is a matrix where all the elements are 0. Now null matrix can be of any type. Can be a rectangular matrix, a row matrix, column matrix. Let's see. So it can be a column matrix, a row matrix, a square matrix. That is, it can be a rectangular matrix, column matrix, row matrix, square matrix, any. So if all the elements are 0, then such a matrix is a null matrix or a 0 matrix. Now we define a square matrix. A matrix which consists of equal number of row and column is called a square matrix. In case of a square matrix, as we know, a square, all sides are equal. In a matrix, if the number of rows is equal to the number of columns, such a matrix is a square matrix. So we define it this way: A11, A12, A21, A22. Clearly there are 2 rows and 2 columns. Now it is important to note why I have used this abbreviation is that A11 is the element at the intersection of the first row and the first column. A12 first row, second column. A21 second row, first column. And A22 second row, second column. So the number Aij, I indicate the roweth position, J indicates the column position. Now there are 2 rows and 2 columns. So it gives the shape of a square and it's a square matrix. Now in a square matrix, a very important property is these elements A11, A22. Now A11 is the element at the intersection of the first row, first column. A22 is the intersection of the second row and the second column. So where I equals to J, that is roweth and column position becomes equal, these are called diagonal elements. So A11, A22 are diagonal elements of a square matrix. Now the line passing through the diagonal element is called principal diagonal of a square matrix. Using this concept of principal diagonal and diagonal elements, we will now define what is a diagonal matrix. A diagonal matrix is a matrix in which all the non-diagonal elements must be 0. So if I consider A is a matrix whose elements are 2, 0, 0, 0, 3, 0, 0, 0, 4. Clearly, other than the diagonal elements, all the other elements are 0. So this is an example of a diagonal matrix. The last type is identity matrix. Now, in case of identity matrix, all the principal diagonal elements must be 1 and all the non-diagonal elements must be 0. So, 1, 0, 0, 0, 1, 0, 0, 0, 1. Now this is an example of an identity matrix. Clearly all the diagonal elements are 1 and all the other elements are 0. Now this is an identity matrix consisting of 3 row and 3 column. So we call it identity matrix of order 3 and we denote it as I3. If we consider identity matrix of order 2, then the elements will be 1, 0, 0, 1. This is a 2 by 2 order matrix and it's called identity matrix of order 2.
So until now, let's have a small recap. We have learned about what is matrix,
Yes.
what are the types. We have learned about the comparable matrix and the equal matrix, and
Yes.
up to now the identity matrix. So there is a question which arises like, is an identity matrix also a diagonal matrix?
It's a very good question, ma'am. This is a question where students often feel that how to connect these two. Then let me make it clear that in case of identity matrix, the diagonal elements are 1 and all the non-diagonal elements are 0. So an identity matrix clearly satisfies the definition of a diagonal matrix, and hence we conclude that all identity matrices are diagonal matrices. But the converse is not true. That is, if I look at A is a diagonal matrix, the elements are 2, 3 and 4. So A is a diagonal matrix, but it cannot be a identity matrix. So we conclude all identity matrices are diagonal matrices, but all diagonal matrices cannot be identity.
Okay, so may I take a call because somebody
Yes.
is waiting for us. Shayan Mondol is waiting with his question. Yeah, Shayan, tell us.
Yeah, ma'am. Hello.
Yeah, we can hear you.
Yeah, ma'am, my question is, what is the basic difference between a set and a matrix?
Okay.
Okay.
Now a set is a collection of well-defined objects. Well-defined, distinct objects. So when we write a set, it consists of elements. Say this is the first 4 natural numbers. The set consists of first 4 natural numbers. So it consists of elements 1, 2, 3 and 4. Now this is, in this arrangement, we do not follow a rectangular pattern. That is, as many elements as there we write separating them by comma, there is no pattern to this arrangement. However, in case of a matrix, there is a definite pattern. That is, the elements must be written using rows and columns in which every element has a specific position in the matrix, whereas in a set, if you note, if I write 1, 2, 3 and 4, and if someone else writes say 3, 2, 1, 4, it does not make much of a difference. However, if I write a matrix 1, 2, 3 and 4, and another matrix 1, 3, 2 and 4, these are completely different matrices. So in matrix, the position of the element is very important. They have a definite position in the matrix, but in case of a set, that is not so. Also, the arrangement, there is a specific arrangement in a matrix, but in a set, there is no such arrangement. Now, we define the operations on matrices. First operation is addition. Two sets, say let us consider two matrices A and B of the same order. Very important, all of you note that these two matrices must be of the same order. If we take two matrices of different order, addition is not possible. So if A and B are two matrices of the same order, then their sum A plus B is a matrix obtained by adding the corresponding elements of A and B. So let us see an example. Capital A is a matrix whose elements are A1, A2, A3, A4, A5, A6. B is a matrix, elements are B1, B2, B3, B4, B5 and B6. Now A plus B, if you want to compute, first check the order, 2 row, 3 column, 2 row, 3 column. So the orders are equal. Now we find their sum by adding the corresponding elements. So A1 will be added to B1, so A1 plus B1, then A2 plus B2, A3 plus B3, A4 plus B4, A5 plus B5, A6 plus B6. So we are adding the corresponding elements, and note that the answer will be of the same order as that of A and B. The next operation that we will define is subtraction of matrices. Now let A and B be two matrices again of the same order. Also subtraction cannot be defined if the two matrices are of different order. Then their difference A minus B is the matrix obtained by subtracting the elements of matrix B from the corresponding elements of matrix A. So A minus B, using the same matrices A and B. A minus B is A1 minus B1, A2 minus B2, A3 minus B3, A4 minus B4, A5 minus B5, A6 minus B6. So we subtract all the corresponding elements A minus B. Next operation is multiplication of a matrix by a scalar. Now, if K is any scalar, what is a scalar? A scalar is any real number. If K is any scalar and A is any given matrix, then the matrix obtained by multiplying each element of A by K is called a scalar multiple of A. So, let us define the product. Using the same matrix A over here, if I choose a scalar K, then K into A is a matrix whose elements will be obtained by multiplying all these elements of A by K. So the elements will be K, A1, K into A2, K into A3, K into A4, K into A5, K into A6. Next operation is very important, that is multiplication of a matrix by another matrix. Now in matrix there are two types of multiplication. There's one is multiplication of a matrix by a scalar and second is multiplication of a matrix by a matrix. Now in this case, let us understand the conditions that is imposed. A is a matrix and B is another matrix. The first question arises is, can we multiply any two matrices A and B? Then if not, then what is the question? What is the condition based on which we can multiply? Now to multiply two matrices A and B, the condition that we must check first is that the number of columns of the first matrix must be equal to the number of rows of the second matrix. That is, if A is a matrix whose order is M by P and B is a matrix whose order is P by N, then the product AB will be defined because the number of columns of the first matrix is equal to the number of rows of the second matrix. If C is the product, then the I, kth element of C will be obtained by the sum of the product of the elements of the ith row of A with the corresponding elements of the kth column of B. Let us understand this thoroughly using two examples. You can write down this question. If A is a matrix whose elements is a row matrix, elements are 1 and 2, and B is a matrix, elements are 3 and 4, find AB and B into A. Then find AB and B into A. So let us first see order of A. There is only one row and two columns, order is 1 by 2. In B, there are 2 rows and 1 column, so order is 2 by 1. Clearly, this is 2 and this is 2, so the number of column of A is equal to number of rows of B, so we can define the product AB. Then A into B will be the product of the first into the second matrix. Now how do we multiply? The rule is we multiply row elements of the first matrix with the column elements of the second. So 1 into 3 plus 2 into 4. So this is 3 plus 8. That means 11. Now clearly note that in the first matrix, the number of row is 1, and in the second matrix, the number of column is 1. So we have 1 by 1 cross 1, and so the order of the answer, that is the product AB, is also 1 by 1. Now let's do the reverse, that is B into A. So B is the first matrix, 3, 4, and A is the second matrix, that is 1 and 2. Let's check the order. Now this is of order 2 by 1. This is of order 1 by 2. Clearly 1 and 1 over here, so matrix multiplication is possible. Now when we multiply, this is the first row and this is the first column. So 3 into 1. Second row, first column, 4 into 1. First row, second column, 3 into 2. And then second row with second column, 4 into 2. So the elements are 3, 4, 6 and 8. Clearly this is of order 2 by 2. It matches with this and this over here. So we see that AB is not equal to BA. So in case of matrices, the product AB and the product BA are not equal. So we conclude that matrix multiplication is not commutative in general. Matrix multiplication is not commutative in general. Very, very important property of matrices.
So
Now,
here a question arises, I think, that is it possible to multiply any of the matrices? I think you have given the answer before.
when we multiply two matrices, then we have to note that the number of the columns and number of columns of the first matrix must be equal to number of row of the second matrix. If that is not so, then the matrix multiplication will not be possible. For example, if I consider a matrix over here 1, 2 and 3 and another matrix 1, 2, 3 and 4. Now if I check the order over here, there are 3 rows and there is 1 column, order is 3 by 1 and this is 2 by 2. Clearly this one and over here it is 2, it doesn't match. So matrix multiplication for these two matrices is not possible.
Okay, so now we have to take a short commercial break, and after the break we'll be sharply come back. Be with us.
ক্লাস 12 এর সকল মেধার ছাত্রছাত্রীদের জন্য
জ্ঞানবিন্দু এবং চ্যাপ্টার ওয়াইজ কোশ্চেন ইনডেক্স
ও 2018 সংসদ মক টেস্ট প্রশ্নাবলী সংযোজিত
রায় ও মার্টিনের
আনসার ফর অল হাইলাইটার এডিশন
বিচিত্রা সহায়িকা সিরিজ।
আপনারা দেখছেন এবিপি আনন্দ, এগিয়ে থাকে এগিয়ে রাখে।
নভেল করোনা ভাইরাস আক্রান্ত দুজন পজিটিভ পেশেন্টকে এগরা থেকে বেলেঘাটা আইডি হাসপাতালে নিয়ে আসা হলো। ভবানীপুর থানার পুলিশ আধিকারিক
একজন মানুষ এখানে
যারা ছুটে বেড়াচ্ছেন প্রাণের ঝুঁকি নিয়ে
চাল এবং ডাল ইত্যাদি
করোনা আক্রান্ত ব্যক্তি করোনার সঙ্গে লড়াই তুলে আনছেন সঠিক খবর সবার আগে। যেটা করোনা কভারেজে জীবন তুচ্ছ করা সাংবাদিক ফুলকে ফুল। চোখ রাখুন এবিপি আনন্দে।
এই হলো এবিপি নিউজ নেটওয়ার্ক। আপনারা দেখছেন এবিপি আনন্দ, এগিয়ে থাকে এগিয়ে রাখে। শিরোনাম নিবেদন করছে এলিগেন্ট স্টিল, ইন্ডিয়াস নাম্বার 1 কিউএসটি বার। সবাই চেনে তাই কেনে।
2 সপ্তাহের জন্য দেশে বাড়ল লকডাউন। 17ই মে পর্যন্ত লকডাউনের মেয়াদ বৃদ্ধি। বন্ধ স্কুল, কলেজ, রেস্তোরাঁ, সেলুন, সিনেমা হল, রেল, মেট্রো, বিমান চলাচল। নির্দেশিকা স্বরাষ্ট্র মন্ত্রকের। দেশে করোনায় মৃতের সংখ্যা বেড়ে 1218। গত 24 ঘন্টায় দেশে মৃতের সংখ্যা 71। আক্রান্ত সংখ্যা ছাড়ালো 37,000। গত 24 ঘন্টায় আক্রান্ত প্রায় 2300। করোনা প্রতিরোধে মার্কিন মুলুকে জরুরি ভিত্তিতে রেমডেসিভির ওষুধ প্রয়োগে ছাড়পত্র এফডিএর। স্বীকৃতি ট্রাম্পের। পরীক্ষাতেই নিয়ন্ত্রিত হয়েছিল সংক্রমণ, দাবি ফার্মা সংস্থার। রেশন বিক্ষোভ অব্যাহত। পরিস্থিতি স্বাভাবিক না হলে অশান্ত জায়গায় সাময়িকভাবে রেশন বন্ধের সিদ্ধান্ত। স্বাভাবিক হলে ফের চালু পরিষেবার সিদ্ধান্ত নিচ্ছে রাজ্য। খবর নবান্ন সূত্রে। গৃহবন্দী পড়ুয়াদের জন্য এবিপি আনন্দে সরাসরি বাংলা শিক্ষা ক্লাসরুম। দুপুর 3টায় দ্বাদশ শ্রেণীর ইংরেজি ও দশমের সাঁওতালি আনাট। জন্মদিনে সত্যজিৎ রায়কে শ্রদ্ধার্ঘ্য। মহান স্রষ্টার স্মৃতিচারণায় সৌমিত্র চট্টোপাধ্যায়। মানুষপুত্রের চোখে সত্যজিৎ, রাত 10টা।
শিরোনাম নিবেদন করছে এলিগেন্ট স্টিল, ইন্ডিয়াস নাম্বার 1 কিউএসটি বার। সবাই চেনে তাই কেনে। সহযোগী নিবেদক ডাফ এন্ড ডটের গ্রামার কোশ্চেন বাঞ্চ, রাইট ট্র্যাক, ডাফ এন্ড ডট, আনমোল ডেয়ারি ক্রিমার ফর এ পারফেক্ট কাপ অফ টি, শালিমার শেম গুঁড়ো মশলা, জীবনের আসল স্বাদ।
বিরতির পর ফিরলাম লকডাউনে ক্লাসরুম নিয়ে। স্যার, ক্যান ইউ শো আস সাম sums about this regarding this topic?
yes ma'am, now we will solve questions on all the topics that we have learned. Let's summarize all the operation and do a few sums. Now if you look at the first question that appears on your screen, that is, if A is a matrix, elements are 1, 2, 2, 1, then find f of A. Now what is f of A? Let me clearly define this first. fx is a polynomial, that is 2x squared minus 2x plus 3. Okay, now respect to this polynomial, we have to first find the matrix polynomial. How to find the matrix polynomial? If I replace the variable x by matrix A, then this becomes a square minus 2a plus 3. Now note, 3 is a constant and these two are matrices. So whenever there is a constant in a corresponding polynomial, we must multiply it by the identity matrix of the same order. Now A is a matrix of order 2 by 2, so this will be also I2. Now let us calculate. What is A square? Now A square means matrix A multiplied by itself. So this will be 1, 2, 2, 1 multiplied by 1, 2, 2, 1 minus 2 into 1, 2, 2, 1 plus 3 into 1, 0, 0, 1. Now, first two matrices when I multiply row with column. So 1 into 1 plus 2 into 2. Second row with the first column. So 2 into 1 plus 1 into 2. Then first row, second column, 1 into 2 plus 2 into 1. 2 into 2 plus 1 into 1 minus, I will multiply all the elements, so 2, 4, 4, 2 plus 3, 0, 0, 3. So over here, 2 2s are 4 plus 1, 5, and this is 4, this is 4, and this is 5. So first what we did is matrix multiplication, this multiplication of matrix by a matrix. Now over here, 2 into scalar multiplication, 3 into this is scalar multiplication. Now if you look, there is a plus sign, so we add these two matrices. So 5 plus 3, 8, 4 plus 0, 4, 4 plus 0, 4, 5 plus 3, 8, minus 2, 4, 4, 2. Now this is matrix subtraction. So we subtract the corresponding element, that is 8 minus 2, 4 minus 4, 4 minus 4, 8 minus 2, and so we get 6, 0, 0, 6. Now that is the answer. So first step was matrix multiplication, then scalar multiplication, then we did matrix addition and matrix subtraction to get to this particular result. Now let's focus on the second question. It says, if A equals to alpha 0, 1 and 1 and B equals to 1, 0, 2, 1, okay, and is given A square equals to B, then find the values of alpha. And this is a very important question. This type of question comes in your board examination. Now first, let us compute what is A square. So alpha 0, 1, 1, alpha 0, 1, 1 equals to 1, 0, 2, 1. Now this is the equation. Now if I multiply this equation, alpha into alpha is alpha square, 0 into 1 is 0, 1 into alpha is alpha, plus 1 into 1 is 1, then alpha into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, plus 1 into 1 is 1. So this is matrix multiplication and this is equal to 1, 0, 2, 1. Now using equality of matrices, we have learned if two matrices are equal, then all their corresponding elements are equal. So over here, alpha square must be equal to 1 and alpha plus 1 must be equal to 2. So alpha square equal to 1 and alpha plus 1 equal to 2. Alpha square equals to 1 gives us alpha as plus minus 1 and alpha plus 1 equals to 2 gives alpha equals to 1. Now note, we have got two different values of alpha. In one place plus minus 1, another place equals to alpha equals to 1. Now in the question it was asked, find the value within bracket s of alpha. Students get confused that there must be always multiple value. No, if there is s within bracket, that can be one value or multiple value. In case of matrices, the answer should satisfy both the equation. So alpha plus minus 1, alpha equal to 1, common value is alpha equal to 1, so alpha equals to 1 is your answer because it's a common value of the two equation. One more thing, if you put alpha equal to 1 over here, then 1 plus 1 gives you 2. But if you put minus 1, then minus 1 plus 1 will give you 0, which doesn't match with this 2. So alpha equal to minus 1 doesn't satisfy the matrix and hence cannot be the equation. So the answer here will be alpha equal to 1. Now we will discuss a new topic, that is transpose of a matrix. Now if A is a square matrix, if A is any matrix of order m by n, then transpose of A is a matrix of order n by m, which is obtained by interchanging the rows and columns of A. It is denoted by A transpose, that is A with T at the top or A prime. Any one of the two symbols can be used. Now let's understand this using an example. A is a matrix A1, B1, C1, A2, B2, C2. Then A transpose will be obtained by interchanging the first row into the first column. So A1, B1, C1, and the second row into the second column A2, B2, C2. So this is A transpose. Check, there are 2 row and 3 column. Over here there are 3 row and 2 columns. The order gets interchanged. So this is A transpose. Now if I say how to relate this in everyday life, remember the television screen that you see or the smartphone screen that you use are all pixel matrices. Now in this matrix, when you use the option to rotate a screen, then what happens is a row becomes a column and a column becomes a row. So this is a practical example of use of transpose in our everyday life. Now let's focus on
properties of the transpose.
Yes, ma'am. Let's focus on the properties now. Next slide, please. Yes. Now, properties of transpose. The first property that you can see on the screen is A transpose whole transpose equals to A. That is, if I transpose a matrix, row becomes column and column becomes row, then again transpose it, then it goes back to the original matrix A. So A transpose whole transpose equal to A. Property 2, A plus B whole transpose equals to A transpose plus B transpose. That means transpose of sum of two matrices equals to sum of their transposes. Third, A minus B whole transpose equal to A transpose minus B transpose. That means transpose of difference of two matrices is equal to difference of their transpose. Fourth, K, where K is any scalar, that's a real number, then K into A whole transpose equals to K into A transpose. Now understand this, that K is a scalar and so it's not affected by transpose. So we have K into A transpose on the right side. And the last very important property is A into B whole transpose is B transpose into A transpose. Now note the left hand side is AB whole transpose, right side is B transpose into A transpose. So this property 5 is called reversal law of transposes, where the product is the order in which the two matrices are multiplied is reversed after taking transpose. Now, based on the concept of transpose, we can now define two more types of matrices, that is a symmetric matrix and a skew symmetric matrix. Now, what is a symmetric matrix? If capital A be a square matrix such that if A transpose equals to A, then A is called a symmetric matrix. Let us see the example. A equals to 1, 2, 2, 4. Now, if I take transpose of this, then the first row becomes the first column 1, 2. The second row becomes the second column 2, 4. And we see there is no change to it. That is, A transpose is equal to A. So, this is an example of a symmetric matrix. Now, let us consider an example of a skew symmetric matrix. A skew symmetric matrix is a square matrix in which A transpose must be equal to minus A. So let us consider an example. A equals to 0, 5, minus 5, 0. Now A transpose equals to, so the first column becomes the first row, the second column becomes the second row. Now we see that we have minus 5 above and 5 below. So this is equal to minus of 0, 5, minus 5, 0 and equals to minus of A. So clearly A transpose equal to minus of A. When A transpose equals to minus of A, then it is called a skew symmetric matrix. Now all of you note that in the example that I selected, look at the principal diagonal elements. The principal diagonal elements of a skew symmetric matrix must always be equal to 0. This is an important characteristic of a skew symmetric matrix. So the principal diagonal elements are all 0 and other elements are equal in magnitude but opposite in sign. It is as if you put a mirror on the principal diagonal, if you put a mirror over here, then all the elements on either side of the mirror will be equal in magnitude, but only their sign will be different. But whereas for a symmetric matrix, you put a mirror over here, then all the elements on either side will be exactly identical. That is, it will appear as if one is a reflection of the other. Now, let us focus on a few questions based on symmetric and skew-symmetric matrices. Next slide, please. Okay, before I start answering the question, let us see the result that is appearing on your screen. That is, if A is a square matrix of order n, then the following results are always true. Number 1, A plus A transpose divided by 2 is a symmetric matrix. A minus A transpose divided by 2 is always a skew-symmetric matrix. That is, if I add a matrix to its own transpose, then the sum divided by 2 is symmetric and the difference divided by 2 is skew-symmetric. Now, if you see it is any matrix A can easily be written as A plus A transpose plus A minus A transpose, because if you take half common, A transpose cancels, half into 2A is A itself. So every square matrix A can be expressed as a sum of a symmetric matrix and a skew-symmetric matrix. Now we go to the first question. The first question says, show that A plus A transpose is symmetric if A equals to the square matrix 2, 4, 3, 5. And these are the elements. I have to prove A plus A transpose symmetric. Now during the examination, take your time and do the steps correctly. Your first step that you should do is calculate A transpose. That is 2, 4, 3, 5. You do this correct, you get your first marking. Next, we calculate A plus A transpose. That is 2, 4, 3, 5 plus this. So which is equal to, now if I add 2 plus 2 is 4, 4 plus 3 7, 3 plus 4 7, 5 plus 5 10. So we get this matrix. Now if we look, if I put a mirror over here, 7 and 7 appear as if they are images of one another, and over here this is a symmetric matrix. Now let's verify this. A plus A transpose whole transpose is equal to 4, 7, 7, 10 whole transpose. So if I transpose this, I get the same matrix, that is A plus A transpose. A plus A transpose whole transpose equals to A plus A transpose, and hence A plus A transpose is symmetric. Okay, so first what we did, we computed A transpose, then we find the sum A plus A transpose, and then we verify that A plus A transpose whole transpose equals to A plus A transpose itself. This proves that A plus A transpose is symmetric. Now we refer to the second question. If A equals to 5, A, B and 0, the four elements are 5, A, B and 0, and is given A is symmetric, we have to show A equal to B. Now for this type of sum, always learn the definitions correctly. A is symmetric. This means, since A is symmetric, hence A transpose must be equal to A. Now what is A transpose? Again, compute A transpose properly. You get your first marking for computing A transpose. So 5, A, B, 0. A is 5, A is 0. Now these two matrices are equal. So from the concept of equality of matrices, the corresponding elements must be the same. So if I equate these two, or if I equate these two elements, then we get A equals to B. This completes the proof. So this type of questions are for 2-mark questions that you get in examination. So Computing A transpose and then finding the proof are the two important things you should focus on when you're solving this type of questions in your examination. Now, using this concept of transpose, let's see what we have covered. First, we had covered all the types of matrices, then operations, then sums on operations. Then we did transpose, we defined symmetric, we defined skew symmetric matrix. Then we did sums on properties of symmetric and skew symmetric matrix. Now we have come to the last and the most important segment of this class, that is elementary operations.
Before starting the elementary operation, we have someone in our phone line. Koel Moitro is calling us. Yeah, Koel, tell us.
Ma'am, my question is, what is null matrix?
What is null matrix? I think sir has given
Yes, I had given the example. Null matrix is a matrix where all the corresponding elements are zero. That is, it can be a rectangular matrix where all the elements are zero. It can be a square matrix where all the elements are zero. It can be a column matrix, or it can be a row matrix. If all the elements are zero, it's a null matrix, or it's also called a zero matrix. Now we proceed to elementary operations. Now first I will write 4 matrices on the board. When I'm writing it, go through the matrices and try to find how are these matrices connected with each other. Now A is a matrix whose elements are 1, 2, 3, 4, 5, 6, 7, 8, 9. B is a matrix whose elements are 4, 5, 6, 1, 2, 3, 7, 8, 9. C is a matrix whose elements are 2, 4, 6, 4, 5, 6, 7, 8, 9. And D is a matrix 5, 7, 9, 4, 5, 6, 7, 8, 9. Observe these matrices carefully. Now, if you look at A and B, I'm sure by now you have understood how are they connected. Yes, the 2 rows has been interchanged from the original matrix. So what I have done over here is interchanging R1 and R2. So the first elementary operation is interchange of 2 row or 2 column of a matrix. So if I interchange 2 row or 2 columns of a matrix, then that is a elementary operation, is the first type operation. Now I move to the second type. If you look at A and matrix C, what is the change? If you observe row 2, row 3, no change. But all the elements over here, and look at all the elements over here, 1 into 2 is 2, 2 into 2 is 4, 3 into 2 is 6. That means the operation is R1 changes to 2 into R1. All the elements of R1 have been multiplied by 2. That means multiplying the elements of a row by a non-zero scalar quantity k is an elementary operation. It can be a row or it can be a column. Now A and D, if you check, then the elements of the first are obtained by adding the elements of the first over here. So 1 plus 4 gives you 5, 2 plus 5 gives you 7, 3 plus 6 gives you 9. That means over here the operation is R1 changes to R1 plus R2. That means all the elements of R2 have been actually multiplied by 1 and then added to the elements of R1. It is very important. Please note that when you write this type of operation, the row that you change, that element will come first. If R1 changes, R1 will come first, followed by the second row or the third row's elements you're adding to the elements of R1. So we have discussed all the 3 types of elementary operation. That is interchange of 2 row or column. Second is multiplying the elements of a row by a scalar quantity k, where k is not equal to 0. And third, the addition to the elements of any row or column, the corresponding elements of any other row or column multiplied by any non-zero real number k. Now, based on this elementary operation, let us define equivalent matrices. Now, if you see A and B, A and C, A and D, then the matrices B, C and D has been obtained by applying some elementary operation on A. Now, then how are they related to each other? B is equivalent to A, C C is equivalent to A and D is equivalent to E. That is, if a matrix B is obtained by applying finite number of elementary operation on matrix A, then B is said to be equivalent to A, and we denote it as A equivalent B, A equivalent C, and A equivalent D. This is the concept of equivalent matrices. Now we define invertible matrix.
So in between them, we have a call,
Sure.
and Shoptom Singh is calling from Kanpur. Shoptom, we can hear you. Hello.
Yes, sir.
Yeah.
Ma'am, my question is, what is diagonal matrix?
What is diagonal matrix?
Shoptam,
Sir has already described it.
Yes, I have explained it when I discussed types of matrices. A matrix in which all the non-diagonal elements are 0 is a diagonal matrix. For example, say 4, 0, 0, 0, 5, 0, 0, 0, 7. Now, all the non-diagonal elements are 0, then such a matrix is called a diagonal matrix. Now, we define invertible matrix. A matrix A is said to be invertible if there exists a matrix B such that A into B equals to I equals to B into A. Now, A is a square matrix such that there exists another matrix B. If it exists, then A into B equals to I equals to B into A and satisfies this condition, then B is called inverse of matrix A, and B is written as A inverse. Now, such a matrix B may exist. If it exists, then A is invertible. If such a matrix does not exist, then A is not invertible. We have to calculate and see whether it exists or it doesn't exist. Now,
So here comes, I think, another question. That is it possible to find the inverse of a rectangular matrix?
yes, ma'am, this is a very important question. Thank you for the question, ma'am. Inverse of a rectangular matrix. Students often, in the moment they get a matrix, start to compute the inverse. But note that define that A must be a square matrix. Now, why? The condition for invertible matrix is that the product AB must be equal to I, must be equal to B into A. That is, A into B must be equal to B into A. Now, from the concept of matrix multiplication of a matrix by a matrix, right at the beginning of the class today, I explained that the order is very important for matrix multiplication. The product AB and BA, both multiplication is only possible if they are square matrices, and at the same time, because it's not only whether product is possible or not, they also must be equal. That is, the corresponding elements of the product AB and the product BA must be equal. This is only possible if both the matrices A and B are square matrices and not rectangular matrix. So, inverse of a rectangular matrix does not exist. Now, using the concept of elementary operation and invertible matrix, we will now solve a question which comes for 6 marks in your INC examination, that is computing inverse of a matrix using elementary operations. The first question is that a matrix is given to you whose elements are 3, 10, 2 and 7. Let A equals to 3, 10, 2, 7. This is the matrix. Now, if you are using elementary operation, remember 3 things. Point 1, you must apply same operations on both sides. Okay, the operation that you are applying on the left should be also applied on the right. Second, when you are doing elementary operation, either apply elementary row operation throughout the sum or apply elementary column operation throughout the sum. Do not mix them up. We often see students that apply 2 steps, they apply row operation, then they start with column operation. That is not allowed and that is not permissible. So, either apply row or apply column operations. Apply both the operations on both sides. If you are using row operation, then you will write A equals to IA. And if you are using column operation, then you will write A equals to AI. Now, after writing this, we write down the matrix 3, 10, 2, 7, 1, 0, 0, 0, 1, 0, 0, 1 into A. Now, the whole objective is that to obtain a matrix B over here such that the product will be equal to identity. So we want to convert this left-hand side matrix into identity. What is identity? 1, 0, 0, 1. So the main objective is to bring 1 over here and 0 below. So the first operation to get 1 over here, I'm applying R1 changes R1 minus R2. So 3 minus 2, 1. 10 minus 7 is 3. The second row remains as it is. Now, don't forget, if you do any operation on the left side, the same operation will be on the right side. So 1 minus 0, 1. 0 minus 1 is minus 1. 0, 1. So this is the first step. We obtained 1. Now, using this 1 that we have obtained, we want to get 0 over here. How to do it? If I multiply this 1 by 2 and subtract, then 2 minus 2 into 1 will give me 0. So my second operation is R2 changes, R2 minus 2, R1. Okay? So the first row remains as it is. 2 minus 2 into 1, 0. 7 minus 2 into 3, 2 into 3 is 6. 7 minus 6 is 1. So 1 minus 1, 0 minus 2 into 1 is minus 2, 1 minus 2 into minus 1, that is plus 2, so 1 plus 2 is 3.
So now it's time to give the assignments to the students.
Okay. Now just one step left. Using this one we get 0 over here. So the operation will be R1 changes, R1 minus 3, R2. So 1, 0, 0, 1. So 1 minus 3 into 2 is over here 6, is plus 1 is 7. Now minus 3 into, I say is minus 9, minus 9. Minus 1 will be minus 10, minus 2, 3. So clearly I equals to B into A, therefore P equals to A inverse, that is 7 minus 10 minus 2 and 3 is the EB, that's the inverse of matrix A. This is how, applying elementary operation, we can find inverse of a matrix. There are two other questions given over here. Now remember, while finding inverse of a matrix, say you get 2 0 in a row or 2 0 in a column, then inverse of such a matrix does not exist.
Okay, so please, now it's time to give the assignment.
Sure, ma'am. Now we move to the assignment. The first question is find a matrix A such that 2A plus 3X equals to 5B, where A and B are given. Second question, if A equals to 1, 2, 2, 1, then show that A square minus 3A equals to 2 into A. Third question, if A equals to 3, 1, 7, 5, find the values of X and Y such that A square plus X into I2 equals to Y into A, and I2 is identity matrix of order 2. And finally, two questions of inverse are given. Now here I just make a note that when I'm getting 1, 0, 0, when it is using 3 cross 3 order matrix, then getting 1, 0, 0, you get your first marking. Then when you obtain, if you obtain this by applying elementary operation, you get your first marking. Then when you apply elementary operation on the second row, you obtain 0, 1, 0, you get your second marking. And then finally, when you apply elementary operation on the third row to get 0, 0, 1, and at the same time write A inverse correctly, you get your final mark.
I think there should not be much questions and doubts to the students. You have such descriptively, you have answered all the questions, and now it's time to conclude the program. And tomorrow there will be the ICSE Maths program from 12 to 1 p.m. Inequations will be the topic. আর আজ দুপুর 3টে বাংলা শিক্ষা ক্লাসরুম তোমরা যেমন জানো আজকের বিষয় দশম শ্রেণী এবং দ্বাদশ শ্রেণীর জন্য দ্বাদশ শ্রেণীর শ্যাল আই কম্পেয়ার দি ইংলিশ আজকের বিষয় এবং দশম শ্রেণীর জন্য সাঁওতালি আনাচ আজকের আলোচনার বিষয় থাকবে। লকডাউনে ক্লাসরুম আজ এ পর্যন্ত। সব খবরের জন্য আপনাদের চোখ থাক শুধুমাত্র বিপি আনন্দে।